All right, let's talk about our cities. We tend to think of them as just places we live and work, right? But what if I told you they're also something else? What if they're actually massive, untapped mines, just packed with treasure?
Seriously, just think about that for a second. What if our biggest source of raw materials wasn't some hole deep in the ground, but was actually all the buildings standing right in front of us? I know, it sounds a little like science fiction, but this is a very real idea that is totally changing how we think about building a sustainable future. And this whole concept has a name. It's called urban mining. It's exactly what it sounds like. It's the process of reclaiming all those valuable resources from our built environment. So instead of digging up new metals and minerals, we harvest them from buildings that are getting renovated or torn down. We're literally turning would-be waste back into a resource. So just how much material are we talking about here? I mean, how much valuable stuff is really locked away inside this hidden resource? Well, the scale it's truly staggering.
Scientists are starting to talk about our cities in a completely new way. A recent study calls them anthropogenic material reservoirs. Now, that's just a really fancy term for a beautifully simple idea. Our cities are man-made mines, and they are filled to the brim with materials just waiting to be put back into circulation.
But, and it's a big but, there is a huge roadblock. We know all this treasure is out there, but we have basically no idea where to find it. It's like having a treasure chest with no map. And this is the single biggest challenge for urban mining today, this giant information gap. See, for this whole urban mining thing to really work, to do it at scale, we need answers. What exactly are our buildings made of? How much of that material is actually there? And crucially, where is it located? Right now, that kind of detailed inventory, it just doesn't exist. This whole problem really boils down to three key questions that everyone, from city planners to recycling companies, needs answered. First, what's actually in the buildings? Two, where are the biggest stashes of it? And three, when are those buildings going to reach the end of their life? Making all those materials finally available for us to use. So, how in the world do we create the treasure map that we so desperately need? Well, researchers are turning to a super powerful new ally, artificial intelligence. They are literally training AI models to become material detectives. And these detectives can survey our cities on a scale that was just impossible before. And the workflow they came up with is actually brilliantly straightforward. Okay, step one, you collect thousands and thousands of images of buildings that are already out there, publicly available. Step two, you train an AI model to recognize different building materials just by looking at them. And then, step three, you unleash that AI on an entire city to map out exactly where everything is. So where do these AI detectives get their clues? Well, they're looking in two key places. For the walls, the facades, they're using images from Google Street View. And for the roofs, they're analyzing high-resolution aerial photos. It gives them this complete picture from the ground up and the sky down. Okay, let's actually see how this works. The whole process starts with a normal aerial photo, just like this one. To you and me, it just looks like a neighborhood, right? But to the AI, this is an incredibly data-rich environment that's just waiting to be decoded. And then, bam! Look at this. After the AI model gets its hands on it, it automatically detects, outlines, and even color codes every single roof by what it's made of. It can tell the difference between tile, metal, and concrete, all in a fraction of a second. It's incredible. The researchers actually put together a whole team of AIs, like a two-detective squad. The facade detective was a model called ResNet50, and it hit about 80% accuracy classifying walls from the street. Its partner, the roof detective, YOLOv8, got about 70% accuracy identifying roofs from the sky. Each one is a total expert in its own field. So, the tools are built, they've been tested. What actually happens when you put these AI detectives on a real-world case? Let's take a look at what they managed to dig up. So for the pilot study, they went to Southport North, which is a part of Australia's Gold Coast. And they picked this area for a very specific reason. It has this amazing mix of different building types. You've got single-family homes, commercial high-rises, industrial warehouses, the whole shebang. It was basically the perfect challenge for the AI. And the results were pretty fascinating. The AI discovered that over 94% of all the building exteriors were made of just two main things: concrete and aggregates making up about half, and masonry, like bricks, making up another 44%. That kind of focus tells recyclers exactly what they need to be ready for. But here's where it gets really, really cool. The truly game-changing part was the spatial data. The AI produced these absolutely stunning, detailed treasure maps. So this heat map right here, it shows you the concentration of face brick across the entire district. The darker blue and purple spots, those are the brick hotspots. That's where the treasure is buried.
And it's not just for bricks. Here's another map, this time showing the density of concrete roofs. I mean, this level of detail is just transformative. For the very first time, city planners and recycling companies can see exactly where their most valuable resources are located, literally on a building-by-building basis.
Okay, so we've got the map. What does that actually let us do? How does having this data help us build a more circular, more sustainable future? Well, this is where it all comes together. With maps like these, cities can decide to build recycling plants right next to the material hotspots, which slashes transportation costs and emissions. Demolition crews can switch from just wrecking a building to carefully deconstructing it. Planners can even start to predict the future supply of recycled materials. This kind of data really does pave the way for a true circular economy, and it helps us break our reliance on digging new stuff out of the ground. Ultimately, what we're talking about here is a complete shift in how we see our cities. Buildings stop being just these static, passive structures. They become dynamic reservoirs of resources, a living library of materials that can help us plan for a smarter, more sustainable future for decades to come. And that kind of brings us right back to where we started. We are now developing the tools to map these urban minds with unbelievable precision. And that leaves us with one last really exciting question to think about. Now that we can finally find the treasure, what amazing, innovative, and sustainable things are we going to build with it?